All right. Let's get busy. Back to exorcism. Let me see. Let me see. Okay. So I was supposed to be doing the tickle, basically, right? So let's see here. Exorcism, tickle, acronym. Okay. So if we go into here, what we want to figure out is how to do the regex, right? And I don't know. I'm going to remind myself again. So this is what I kind of had for the acronym. And let's see. That's probably more than necessary, but basically I was supposed to be looking at like the tickle regex information. So they have a particular like flavor, I guess. So we'll see how this goes. So basically, if I start with like, let's see, let's open up acronyms here. If I start with one of the acronyms that we've got, like ASAP, okay, sure, let's start with an acronym like this. And then if we put regex here, and then we put a pattern, like, say, the word boundary and then dot, and then we say we want all. Okay, so it didn't match. So the word boundary like this, that might not be a thing. So what about white space? Oh, okay, so we can match that. Okay. So can we match that or something at the beginning of the string? Yeah, okay. And then what was it to show the matches? It was inline, right? Inline. Okay, so we can see that we've got AA, SS, AA, PP. Okay, so sure, yeah. So those are them. All right, so then I guess my question then would be, how can I turn this into into my acronym? What if I get rid of this? Okay, that's better. So then can we smush that down and get rid of those like brackets and things? Okay, let's see. Okay, so let's look at regex. So I think we have some pretty good stuff for like string processing here, don't we? Can we do if we were to do like a substitution? So like if we do inline, can we make that into a string and then do a substitution on that? Return as a list. So inline returns as a list the matches. Okay. So maybe what we want instead is to do like a regex substitution. Okay, so for example, if we were to do a reg sub, close this actually, this keeps opening. A reg sub, then in this case we don't do inline, but we do, I don't think we even want all either, do we? Maybe. Yeah, maybe we want all. And then we would do a reg sub where this part we want to keep, but then any non-white space after that we want to get rid of, right? So then the substitution would be with and. Nope, that's not it. Okay, so the and is like the whole match or something? So maybe we want like a and 1 or an and 0, something like that. Okay, so we want slash n, right? I think. Yeah, I think so. Okay, let's try that. Okay, so that's ASAP. Okay, cool. And then like once we have that, can we then sub out the white space? So we have white space, we have that, and we want to sub that out for nothing. Extra characters after close brace. So no. But what we could do is can we do set inits and set it to this? Wrong number args should be set var name new value. Okay, if we have parens around here, will that help? No, extra characters after close brace. Huh, okay. We're gonna learn how this works. Okay, so set variable. So assigning values, set fruit cauliflower, okay. Set can also be invoked with only one argument. When called with just one argument, it will return the contents of that. Oh, well, why is interesting? Okay. Okay, okay. All right, so index, running, assigning, substitutions. Okay, yeah, so we want to substitute the output from the regex and use that to set the variable, right? So they set, puts, set, okay. Okay, so here we did a substitution. All right, what's next? Set, puts z label z. Okay, next. Ah. Okay, so let's try it with the square brackets. What does it say? You obtain the result. Okay, let's use the square brackets. So we'll have square bracket here and here, and then set inits. Okay, so now if we put inits, do we see it? Shoot. Oh no, we have to put the dollar so we can get it subbed. Okay. All right, so then we want to... Okay, so after we set the inits like that, and in fact, let me put this into my file, because this looks like an okay start. Okay, so here we have a procedure, and I am going to do this. Set inits, and then let's put the phrase in here. Right? And then here, let's set acronym, and then here it'll be reg sub all white space, or yeah, white space, there we go. And that's in inits, and then we just set that to nothing. Okay, and then let's see where's proc. Adding new commands. Okay. And then we return. So let's return acronym. And honestly, I think that's a pretty good start. Hey, I haven't been at it too long yet for this session. That's a pretty decent start. Maybe. Let's see what happens when we run it. Okay, so it passed one. What one did it pass? Okay, so if I have a file here, can I open up that file into my TCL/sh? TCL/sh open file. File access. So it's a source code file. Let's see. So it's not necessarily like that. No? Okay, so there is exit. Okay. Okay, so I think let's just put this out. And then in here, can we maybe just paste this in? Okay, so now can we abbreviate as soon as possible? Can we do it with... Okay. Okay, so that one is all right. Now let's look at some of these others. So let's do liquid crystal display. Okay, so I got L and then I got a small d. So let's see if we can do T equal to uppercase, maybe? Sure, let's see what he says. Use string to upper. Okay. And they link to here? Wonderful. That's amazing. All right. So let me paste this. No. Hold on. Let's go back to the file. And here, let's say set upper acronym as string to upper acronym, right? And then return upper acronym. Okay, so then if we paste this here, and obviously I didn't handle the dash yet, but let me just see this part. And then can we abbreviate liquid crystal display. Okay, LD, so that's better. All right, so now in my reg sub, I have it like something following a white space, but I could have it follow a dash as well. And in my other one, I used underscore and star also, so let's do dash underscore and star. Right here. So this one, it could be a white space, but it could also be a dash, underscore, or star. Okay, so let's copy that, paste, abbreviate, liquid crystal display. Couldn't compile. Oh, invalid character range. Oh, there's a dash, so that has to be a literal dash. I should have realized that. Or does it? Does it have to be a literal dash? I think probably, yeah. I don't know if that's the problem, but we'll find out here in just a sec. So let's copy, paste, abbreviate, liquid crystal display. Slow typer. Okay, so it still says LD, so that's no good. Does the other one at least still work? As soon as possible? That one at least still works. Okay. So let me look at the regex syntax. Okay. So we can do a character class, basically, right? Like A through Z, I think. Maybe not. Okay. Wait. Oh yeah, right here. A bracket. Okay, bracket expression. Normally matches any single character from the list. Matches any single character not from the rest of the list. Okay, so that's normal. And the reason mine didn't work is because okay, so we can use a standard character class. Okay, so this is for space, commonly used character classes. And then okay, Let me try that. Okay. Hmm. That doesn't quite make sense, because it did work for ASAP still. Okay, so I think what I want here is not this. I think we want to go either a white space or a dash or an underscore or a star, but that should be a literal star. Okay, so now let's go abbreviate this. Okay, and abbreviate this. No. Darn. Okay. So to include a literal Okay, so you can enclose it in this. Okay. Okay, let's just redo this maybe. Okay, so we want any character that follows a space, a literal dash, a literal underscore, or a literal star. Is that too crazy? It seems like, well, I don't know. Let's see if it works. If it works, it works. But I have no understanding if it's going to work. Okay, let's see. Okay, that still says LD. This one says as soon as possible. Okay, so I think my problem here is that when I did this non-white space, I matched the dash, and I just wasn't thinking properly before. Maybe I'm thinking a little better now. But yeah, so this one, this is going to match that dash and run right over that. So we need something here that can be like not a dash, I guess. But then we're going to have other problems, like if there's a dash just hanging out in white space. But one thing at a time, maybe. So we'll do, oh, shoot. Okay, right here. So this is going to be, okay, so space, not space, note underscore. Okay, gotcha. Okay, so when we have, so if the list begins with this, we can't have that like in the middle, can we? Okay. So we want, okay, so we want a character class that includes alnum. We want to include underscore. We want to include dash. We want to include star. At least for now, I think we want to include these. Yeah, basically. Okay. Okay, so if we paste these in here, ASAP. Darn it, I screwed it up. Okay, so what am I doing? So dash is not supposed to be in there. It's just supposed to... uh, okay, I did exactly sort of the opposite of what I was thinking. That's just being dumb. Okay, so I have a dash in there, but we need to get rid of it. Okay. So now we'll get rid of the dash in the next step. How about that? So this could be that, or... So we're going to get rid of any kind of space, or any kind of dash, or any kind of underscore, or any kind of star. ASAP, LCD. Okay, next one is thank George, it's Friday. Let's see what we get with this one. Abbreviate this. Okay, so I got TGI, but I got an extra apostrophe S that needs to be taken out of there. Okay, so in my other one, what did I do about apostrophes? So I guess I removed all punctuation at the end. Okay. That's not really gonna work. I think I just need to remove any apostrophes before I start. Would make more sense. I'm not sure why I didn't write anything about that there. But let's just try this. So, at the start, let's set, S, I guess, reg sub, all. Okay, so then it's gonna be any, like, of this. Okay, and that's gonna be phrase, and it's gonna be nothing. And then here, this becomes S. Okay, so let's copy this. Thank George, it's Friday. Okay, so then I still have a bang at the end. Let's get rid of that. Yeah, let's get rid of that when we get rid of these other things. So we can have a literal bang here. It's kind of dumb though, because obviously, like, I don't necessarily want to handle every single thing as a special case. That's crazy. Okay, but let's see where this gets us. Okay, so that one's okay. How about that one's okay, and then liquid crystal display. Okay, okay. Works for me. And then let's see what else is in the tests. Okay. Okay, so these are the ones we want to do. Okay, so we'll copy this. And then we will do this. Ping. Okay, we'll do this. ROR, we'll do this. Okay, I've got an extra comma in there. Okay, let's see what happens with this one. That one's okay. So I'm thinking, honestly, I'm just gonna handle the comma as another special case and move on, even though that's dumb. So hard that my dogs came over and licked me. Okay, that's crazy. All right, this one. I'm missing the I. The I should be in there, right? Okay, so that's definitely a problem. Okay, that's a big problem too. I ended up with no N and no T. Oh gosh. All right, well, I'm getting closer. All right, so first of all, I think let's get rid of the comma. All right, and then I have a problem here. Well, what if I have just single letters? Like, I am a clown. Yeah. Okay, well, that's okay. IAAC. So it's the punctuation mark, the dash, that messed us up there, I guess. So I am a clown. So then I missed the C. Okay. So some stuff that I've screwed up here. All right, I'm just gonna add the comma in here as another special case. I don't know. But here, okay. So, but when we get the inits, we're trying to take anything that is after a space or a dash or an underscore or a star or at the beginning. And then whatever is after that, we are trying to replace with nothing. Or no. Wherever something like this appears, we're trying to get rid of this last part, the extra alnu. And that seems to be working okay. So then when we do the acronym, are we getting... No, shoot. I don't know where we're going wrong. Okay, I see where I am going wrong. This cannot be just any character. This has to be an alnum, I believe. And likewise here, this can't just be any character. I think that's actually my only problem there. Okay. Alright, so we're gonna paste this in. I am a clown. Okay, that's fine. TRNT, cool. Which other one messed up? This one? Okay, that looks alright. And this one. Okay, cool. Let's see what happens when we run the test. It says passed 1, skipped 8. Okay, so let's go into the test. Acronym test. Okay, so I have test. Okay, then I have skip. Okay, here we go. 9 passed. Awesome. See, that wasn't so bad. That wasn't so bad. And you know why? Because the regexes worked. The regexes worked. This is not at all normally the way I write regexes. And honestly, I'm pretty sure that you can write them much more tersely in this language. But they work, I'm going to leave them alone. Let's submit. Like, if I weren't trying to rush through this whole thing, I would definitely want to refactor almost all of these exercises. But I am deliberately choosing not to refactor because I'm trying to rush through this whole thing. If it works, baby. So that's good. Oh, I meant to. So yes, I'd like to share my solution with the community. Okay, confirm. All right, so now we're gonna close out. And we are gonna go to whatever's next. Okay, so we're marked complete on Tickle. Now we're going to go to PowerShell. Oh yeah! Join the PowerShell trek. I must say, PowerShell is one of the best names, I think, for a programming language. Maybe I'm crazy. Yeah, I'm probably crazy. But I'm gonna stick with my crazy opinion. PowerShell is a great name. Okay, let's go to the installation. All right, so Linux, Ubuntu, okay. So we'll just go step by step, I guess. So we'll do this. Hopefully that's okay. Oh, all right. Yeah, this Corretto AWS, I don't know, man. All right, so then we're gonna do this. Sure. Okay, I think that's fine. Let's try this. Oh, it didn't show anything. I guess we're okay. Let's get this. Whoops. Oh, gosh. Where are we? Where are we? Right here. Repository keys. Okay. Remove that. Sure. Update again. Hit me with the Microsoft stuff, baby. Oh, yes. Okay, sure. And then install PowerShell. Let's take a look. I think this one's going to be smooth. I think the regex support in PowerShell is going to be very, very smooth. Okay, and then we'll try PWSH. Let's take a look. PowerShell! All right, so exit. Okay, let's try running the hello world. Okay. Executable file not found in path? Oh, interesting. Okay, pester. Installing and updating. Okay, so we're going to install that. Right? Okay. And then update. I don't think we need to update when we just installed. Okay. So let's try again. We're going to go exercism test. Okay, it still says failed subcommand invoke pester. So what's the deal? Pester is the PowerShell testing framework. Okay. Okay, so let's look. So, oh, interesting. So when we run exercism test, oh no. So if I go into PWSH and then invoke pester, is that a thing? Uh-huh. Interesting. Interesting. Okay, I think that's good enough. So let's exit and let's edit our file, hello world. Yeah, this one. And let's say hello world. Okay, so then we go into PowerShell, invoke pester, and it says passed. And then we exit and exercism submit hello world. This. Okay, let's take a look. Okay, so processing passed. Amazing. Okay, so we'll confirm. All right. So let's close these out, and now we're gonna go to the next, yeah, this one. So we're gonna copy the exercise. Okay. Acronym. Okay. So for this one, I feel like I just kind of want to basically copy what I did in Tickle because I think everything's going to work pretty similarly. It's like kind of a similar language, I think. That tickle seems like sort of a shell-like language or whatever. So let me just show one more time what I have under acronym. Okay, so this is what I have. So I basically do it in just 4 steps, right? So let me write these down for myself. So step one is remove apostrophe. 2 is just remove all but first letter in word, right? And then 3 is remove white space and punctuation, right? And then 4 is uppercase, and that's it. So it's 4 simple steps. Let's do them in PowerShell. Okay, so let's see. PowerShell regex. I think this is going to work very smoothly. So regular expressions. Oh, wow, really? Is it just that easy? We want to do substitutions, right? It's reg sub, reg sub, reg sub. So they're all substitutions. Okay, groups, captures, and substitutions. Wait a minute. Is that what I need to know? Substitutions, yeah, substitutions. Replace. Oh, is it just that easy? Oh my gosh, I love it. I absolutely love it. Okay, cool. Okay, cool. Let's try it. Okay, so we are gonna get in a param, which is called a phrase. Then it says, please implement this function. Sure. So we're gonna take phrase replace Is it just that? Gosh, it might be. Okay, so then how do we assign? PowerShell assign variable, sure. Do we just do set or something? What do we do? So we just do dollar equals, storing the result. Oh my gosh, so nice. So nice. So I'll say s equals all right. Then I'll say init equals, oh, wait a minute. It's colored differently. Do I need to be worried? Do we use like semicolons or anything? It doesn't show any here, right? Hold on, let me look at it in the shell. So if I go on PWSH, okay, so I want to say phrase equals as soon as possible. Okay, if I do dollar phrase, then it says as soon as possible. If I do dollar, okay, well this one doesn't have a apostrophe, so let me just say it's morphin. Wait, do you do this? Okay, fair enough. It's morphin time. It's morphin time. Okay, so now let's do phrase replace. No? Okay, let me look at replace again. Okay, so that's not quite it. Unexpected token. Okay. You can escape with a back tick. Is that what we want? Or do we want this? No? Unexpected token in expression or statement. Replace. Oh, there's a comma. Okay. There's a comma. All right. Okay, so replace. Okay, so $init equals $s replace. Okay, so then this time we are going to take basic. Oh, man, I'm gonna look at what I had again. No, it was this. Okay, so I had this whole thing. So I'm taking any example where a space dash underscore or star is followed by an alnum, or the alnum is at the beginning. Okay, so this is like this. And then, oh, can we do global or something? Are there like flags? No. What is there? Long description. Okay, so match and replace operators, character literals, word characters, wildcards, white space, quantifiers, anchors. So are there other anchors? What would the other anchors be? Wow. Okay. escaping, groups, captures, and substitutions, named captures, substitutions, okay. Capture groups can be referenced by name, okay. All text match. Oh no. Okay. So we're just gonna try this. So this part is gonna be a word character that is following this, or a word character that is following either a space or a star or an underscore or a dash. All right. So if we go into here and we say, okay, so phrase equals, it's morphin time, and then we do this. Let's take a look. And so $S is its morphin time. Okay, so now let's look at inits. Oh, yeah, great, love it. Easy peasy. All right, let's finish this up before I take up too much more time. Yeah, I think that means I'm just about close to done. Exit. Okay, so that's the first two steps. Now 3 is remove white space and punctuation. So acronym equals init replace, and so that's any sort of white space or these punctuations, and I had comma as another one, and I had bang as another one, which is silly. I'm like handling special cases, which is dumb. And definitely would need some refactoring, but okay, so again, let's go $, it's morphin time, then let's do this. And we have its morphin time, then we want init, IMT, then we want to replace whatever is in there. Acronym, IMT, okay, and then we just want to go uppercase. PowerShell uppercase. To upper, okay. I think that's straight out of the .NET framework. So let's finish up by saying, so do we have to like return something? Oh, okay, hold on. So it's a function. So PowerShell function. Oh my goodness. Okay, so they do this, and you say get version, and then it returns whatever. So does it just return whatever on the last line? Probably. Probably. Okay, so I'm just gonna put acronym to, wait. Yeah, to upper. Let's test. So we gotta go to PowerShell and then invoke pester. Let's see what it says. Okay, so I got TRT instead of TRNT, and that was a problem that I had in the other one as well. And the reason I'm having this problem now is I'm not sure. Let me look. The road not taken. Okay, so it's in underscores like this. Oh, interesting. So apparently I didn't match it. I thought I tried to, but I guess it didn't work. So there's an underscore in here. Okay, but the problem is that it can't be a word. It has to be, yeah, okay. I ran into the same thing in my JavaScript version. So it should be A through Z, and likewise here. Okay, passed. I am ready to move on, baby. Let's submit. Okay. It says processing. I am so ready to move on, baby. I am pumped. Okay, so that wasn't too bad. Let's mark as complete. Confirm. All right. So now we are finally ready to move on. I took forever on Haskell. I feel a little bad about it, but what can you do? All right, circular buffer in C. Let's jump on in. Okay. So before looking at this, so this is a 7-element buffer. Okay, let's join the C track. Okay. This may very well already be good to go, but I'm just gonna try this. We'll see how that goes. Okay, so we're good there. We have some that are no longer required. Sure. Yeah, sure. Hit me with the extra megabyte. Okay, so then we're probably good. So now let's run the hello world and see how this goes. Let's see how it goes, baby. Okay. Okay, here we go. So we're gonna try, let's just try the exorcism test and see where we're at. It says fail. Okay, cool. Everything seems to be good to go. So let's go into the hello world. Nope, not that one. Hello world C, yes. Okay, so we'll return this hello world. And exorcism test, and it says okay. Submit. Nope. This one. Okay, let's look. Amazing. Mark is complete. I am loving it. I am loving it, baby. All right, so now let's go to this one, the circular buffer. We'll see what we get here. All right. Okay, let's look at the README. All right. Welcome to Circular Buffer on Exorcism's C track. If you need help running the tests or submitting the code, check out help. Okay, so a circular buffer, cyclic buffer, or ring buffer is a data structure that uses a singular fixed size buffer as if it were connected end to end. All right. Okay, so starts empty and with a predefined length, okay? Assume that a 1 is written into the middle of the buffer, sure. Exact starting location does not matter. Then maybe add a couple more things. All right, so there they are, 1, 2, 3, sure. So then if we remove 2, then the oldest inside the buffer are removed. Okay, so it's like a queue. So we put in a 1, a 2, and a 3, then we grab something and grab something, and now the 3 is still there. Okay, 4, 5, 6, 7, 8, 9, sure. When the buffer is full, an error will be raised, alerting the client that further writes are blocked until a slot becomes free. We can overwrite the oldest with a forced write. Interesting. So we overwrite the 3 and 4 there with A and B. And then 5 is now the oldest data in the buffer. Okay, so there's space available. If the client, again, uses overwrite to store C and D, then the space where 5 and 6 were stored previously will be used, not the location of 7 and 8. 7 is still the oldest. All right, well, I think it seems pretty straightforward. Okay. What's in the H file? Okay, nothing. All right, so let's start in the H file. Okay, well, let's look in the test. Okay, so for this test, oh wow. Huh, that's a lot. All right, that's cool. Okay, so circular buffer T. Okay, so it's some kind of struct. I'm gonna have to look up a lot of syntax probably on this, but it's all right. It's all right. We'll figure it out quickly here. Okay, so in here we're gonna have a typedef struct circular buffer, and the name is circular buffer T. Okay. So if I run that test, it's going to have a ton of output probably, right? Okay, so inside this circular buffer, like when we create it, do we decide, we presumably decide how much capacity is going to be in there, right? Okay, let me go to the top. Okay, this looks like a lot. Okay, so include circular buffer. We are going to write values, and it takes a buffer. Where does write come from? Oh no, I'm nervous. Okay, let's see. So we have write and we have overwrite. And values is a buffer value. Okay, so buffer value is something else that we're going to have to put. And then read. Okay, so read is something else that we're going to have to create, I believe. I'm going to have to write some of these down. Okay, so we need some of these functions. We need a write function, and all of these were talked about in the README. We're going to need a buffer value t type. Write takes and we need a circular buffer t type. So write takes one of each of those, and so does overwrite. And then let's see. So then read returns an int16t status. Okay. And it takes a buffer, so read takes a buffer and a buffer value pointer. Okay. What else? Here, let me see its syntax highlighted. Okay, so write takes a buffer and a buffer value. Overwrite takes a buffer and a buffer value. Read takes a buffer and a pointer to a buffer value and returns int16 status. Okay, these also return status. They all return status. Okay, pretty straightforward then. And then if we look for like, where are we using this, we can kind of highlight those. Okay, so we're using the, oh, wait. We need to, okay, so we need to note that write and overwrite, they take a pointer to a buffer. Let me write that down. And same for read, right? So they all take the same thing. So write and overwrite, they take pointer to buffer, right? And then they take a buffer value. Okay. Okay, then here we need to have a function for a new, so we need a new circular buffer function, which takes a capacity, which is a size t. Okay. Is delete buffer is another one that we need to create, right? Yeah, it looks like it. So we need to create a delete buffer. Which just takes a pointer to a buffer. Okay. Read. So is the buffer value, I mean, are they just ints? I think the buffer value may just be ints. I think so. Let's see what else. Okay, so we need to note that when we read, so read removes oldest. That's a note that we need to make. Okay, well, this seems like a good exercise. It's probably going to take me a while. I felt like I did pretty okay on the tickle, and the PowerShell only took me about roughly 30 minutes-ish each. Okay, so let's go into circular buffer H. So we're going to have this, and we're going to have type def int, and that's buffer value t. Okay, so then this is going to have a size t capacity, I guess. And C struct definition syntax. I'm gonna have to look some of these up. There we go. Type def. So type def int buffer value t. Okay. And then type def on struct. Oh shoot. So we don't really have type def here. But okay, so union. Okay, yeah. I think this is fine so far, probably. Yeah. Yeah, I think this is okay. So we have type def struct circular buffer. It has a size t capacity, and it has a pointer to a buffer value. I guess it's more like an array. Let's see. So yeah, let's say it's an array. Buffer value t content array. That's probably all that's in there, right? Maybe, maybe. No, that's not true. We probably need to know where the first and last are. So we need a size t first and a size t last. Those probably need to be saved. Unknown type name size t. Oh, let me see what that's about. I think I have to get it from standard or somewhere. Unknown type name size t. It's standard def. Wait, I don't know these details. Standard def.h. Okay, so let's see. Whoops. So include standard def h. Flexible array is not at the end of struct. Oh, okay, let's put that at the end of struct. Cool. All right, then. Okay, so according to my notes, we need a write. Okay, so we know the implementations of these are going to be in the C file. So let's just create. So we know it returns an int16t, int16t, right, which takes a circular buffer t and a buffer value t, right? I think I have to put the names, right? So buffer value. Is that it? Not really. Expected expression. I think this is in the wrong place. There. int16t. It's in the other file, right? Let me just look. So where did int16t come from? Way up here. I guess it must be standard lib, probably, right? That would make sense. Okay. Okay. So then int16t overwrite takes the same things. And then int16t read, almost the same things, except this time this one is a star. Okay, so far so good. And then we need new circular buffer. Oh, did new circular buffer return anything? Yeah, of course, it returns a pointer to a buffer. Pretty obvious, but I didn't have it written down, so I didn't remember. Okay, so yeah, so this returns a pointer to a buffer. Cool. Delete buffer looks like it doesn't return anything. Okay. Okay, so this one is, wait, circular buffer t star new circular buffer, which takes size capacity, right? And then the last one is delete. Okay, so this one's a void. Void delete buffer, which takes circular buffer t buffer. Okay, so I believe that's it for the header file. So I'm going to copy these so we can go put them into the C file. Yeah. Okay, so here they are. So again, let's include standard lib h, yeah? Include standard def h, is that it? It still says unknown type and stuff. Error found in header, oh. All right, what's it say? Okay, maybe this is okay. So I am gonna put a function body here. So that I just have, just gonna finish up these stubs. I'm gonna need to take just maybe a 5-minute break here pretty soon. So I want to get these stubs made first. Okay, so what's this? Okay, so let's, if we do exercism test, what's it say? Okay. Um, okay, fair enough. What's printf for pointer? Okay, P. No, it's not that. What is it? Oh, I think it's just standard IO, actually. Yeah. Standard int? Oh. P. Okay, so these are all unused parameters. All right, so let's fill some of those in. So this one, so this says expects argument of type void star, but argument 2 has type circular buffer star. Oh. Well, I didn't know. I didn't know, but I guess now I do. Size T, so that should be ZU, I think. Okay, let's look. Is that what it is? And then this one, okay, it's okay, value, int. Oh, okay, so that one's int star. So here we have to dereference. Oh wait, no. Here we have to dereference. Okay. Conflicting types for read. Oh. Wait. Int 16t read. So how did I screw that up? No. Oh, I've screwed up so much already. Okay. Clear buffer. Where's clear buffer? That's in test? Okay, so clear buffer is another function that I need that I didn't have written down because I didn't notice it. Okay, so actually let's bat this test again. Clear buffer. Oh, that they have that in quite a few places. Okay, so it's just the same as delete buffer in terms of like the signature. Okay. So this one is clear. Okay. So this one, clear buffer. Okay. So conflicting types for read. And where are we looking here? This is in circular buffer C. Okay, hold on. Okay, let's start from the top. Running test via make. Unknown type name int16. This is in the H. Okay, so let's include the standard int. Whoops. Oh, interesting. Okay, so now it says fail. Okay, so that's all the stubs. I'm gonna step away for like 5 minutes probably, honestly, and I'll be right back. Be right back. So, cool. All right, so felt like it kind of took a long time filling in some boilerplate. This next part might take kind of a long time too. I don't know, we'll see. I mean, I think that the actual problem is perhaps simple-ish. We'll just take it one step at a time. Okay. All right, so the first one is to create a new circular buffer. Okay. So, we know that we are going to need to put on a capacity and a first and a last. So, wait a minute. First and last is dumb. I don't like that. First, let's have first, but instead of last, let's have size. For, like, how many are in there. Yeah, let's do that. Okay, so when we create a new one, we are going to, let me see. So what are the steps? I think we're going to allocate for a, um, for an array, probably, right? Seems like it. It seems like it. I think so. So when we let's see. So let's start filling these things in. So we have the capacity already. So size equals 0. First might as well be 0. Then we're gonna say buffer value t, and then what did I call that in the other one? Hold on. Content. Content equals, let's see, how do we so this one I guess should be mallet. I'm gonna have to look up some information, even though I did this on the channel before, like malloc array. I don't know. Sure, hit me with it. Okay, that's not really the answer. But let's just see what they did here. Okay, so my head is kind of blocking that now, so I'll try to unblock it from my head. Oh. Let's just close this one. Okay, so content. So we just malloc the amount of size that we need. So that is going to be capacity times size of buffer value t. Array initializer must be an initializer list or wide string literal. Can we say that? Okay, so now I'm going to say circular buffer T buffer equals circular buffer T star malloc size of buffer value T. Okay, so then I'm going to say buffer size equals size, buffer capacity equals capacity, buffer first equals first, buffer content equals content, return buffer. And in the header, I think I'm going to make that a star. Maybe? Yeah, maybe. So now it says, okay, so it still says fail. All right, so that's probably good. So I guess it means it compiled. It's a step in the right direction. Okay, so let's do the next one. So let me look. Oh wait, did things actually get printed? Expected 1 was 0. I didn't actually see anything get printed. Oh well. Okay, so the first thing we're going to do is we're going to try to write to this guy, right? Actually, let's make delete buffer possible first. And clear buffer, actually. So clear buffer is going to be literally just set the size to 0. Delete buffer is going to be free buffer content free buffer. And I think that's it. Okay, so then write is going to be I'm going to write this down real quick. So we're going to take first plus size mod capacity, and we're just going to set it there. Yeah, actually, that's literally it. It's that simple, I believe. So we're going to say if buffer size is less than buffer capacity, right? And then we'll say buffer content sub buffer first plus, here, let's buffer first plus buffer size mod buffer capacity equals value, right? And then we return. Oh, what does it say to return when it's successful? So, instructions. I think it's in the test, actually. Let's look in the test. So when we write, we're expecting some particular status, right? So exit success is set to, looks like exit success came from somewhere else. So we're just gonna exit with exit success. And if we don't want exit success, we want exit failure. Okay, that's what I'm gonna do, I think. Return exit success. Right? So then in this other case, we don't do anything. We just return exit failure. Okay, I think that's okay so far. Let's do the next one. Okay, so for overwrite, this is where we don't bother to check. Or rather, let's see. No, I think we do still have to check. It's going to be pretty much this same thing. But the difference is that here we say buffer content buffer first equals value. All right, and then we go buffer first plus plus, and that's what I didn't do here. So when we do this, we need to say buffer size plus plus, and likewise here. And then here, again, it is exit success. Okay. Then we're going to have read. So read always gets first. Now, if there's nothing in there, I think we exit failure if there's nothing in there. Let's see the test again. Read values from buffer. Test reading empty buffer fails. So if we read an empty buffer, it should say exit failure. Okay, cool. All right. So here we say if buffer size greater than 0, then we're gonna say buffer value t popped, or no, actually we're gonna say value equals, I guess, address of buffer content address of buffer content sub buffer first. And then buffer first plus plus. Okay, so another thing I forgot. When we increment that size, oh no, incrementing the size is fine. But if we increment first, then we have to make sure that we mod equals. So buffer first mod equals buffer capacity. Let's not forget that. Okay. So then we return exit success. Okay, so then in this case, we return exit. Okay, expected 61 was 0. Okay, so it's not working yet. That being said, okay, so I have at least filled something in for each function, right? So now we just have to make them work. Yeah, baby. Just gotta make them work. All right. Interesting. Okay, so when we tried to run the test, we went expected 61 was 0. Oh, interesting, interesting. So it was test, wait a minute. Test reading empty buffer fails. Expected 61 was 0. Is 61 exit failure? Okay, it was test reading empty buffer fails. So we said capacity is 1 and read value is 0. Okay. Then we create a new circular buffer, capacity 1, sure. We say status equals read. And then we want to say status should be exit failure. And then what is this? E-no data, err no. Oh, interesting. I actually don't know what that is. The E-no data. Test reading empty buffer fails. E-no data. Okay. Okay, this is a real skill issue. I don't know what this is. So E-no data in C. Wikipedia, huh? Is this what I need? Is the E-no data in here? 61. Okay, so we're supposed to error report saying no data. Okay, okay, that makes sense. There's no data, so we should error report. And then what's the way that we typically do this? Where's this one? Okay, so if we use err no, then we use err info. Is that it? Oh, this is crazy. Okay, err no is a preprocessor macro. So it's saying, what is it saying again? It's saying test assert equal int 16 no data err no. And where all is err no? Okay, so they included err no h. And we have an error no here, error message. Error info. Let's see. so I guess we just go, we set erno to whatever it's supposed to be. Oh, let's try it. Let's try it. So I'm going to say include erno h. Okay, oh, this is a learning process, baby. This is a learning process. Okay, so we know that in this case, we should say erno equals eno data. I don't know, let's see. Oh, pass. Okay. All right, so a bunch of them are ignored. Let's unignore those. Okay, so where does it say if they're ignored or whatever? Test ignore. Okay, so wherever it says test ignore, let's get rid of that. It looks like it's a bunch of places. Okay, let's run it again. Okay, great. So it says we had a pass, and then we did have a fail. It says Malik corrupted top size. Okay, well that's messed up. No! Aborted core dumped. Well, understandable. Okay, so we tried to do Okay. We tried to do test can read item just written. Uh-oh, expected one was 0. Okay, test can read item just written. Okay, so we wrote a 1, or we tried to, but it didn't actually happen. So we tried to say new circular buffer, I guess. And then we tried to write value to buffer. Values length, values, false, buffer. Oh man. So then where did I totally explode it? Not sure yet. Not sure yet. Test can read item just written. Corrupted top size. Okay, let's see. So what we need to do is definitely, so I changed something in a way that was dumb. Um, so this really needs to be an array, I think. Does it? Yeah, I think so. And then in the C file, when we create this thing, we need to go No, not here. That part is fine. It's this one. Buffer value t capacity, where arithmetic or pointer type is required. Cast to okay. Array initializer must be an initializer list. C array initial. Yeah, hit me with initial. DigitalOcean. I haven't been on DigitalOcean docs in a while. They're usually very, very good. Okay, so we can do it like this. Can we do it with a malloc? Is that crazy? Okay, so I think we need to not do any of this. I think we just need to say what'll that do for us? Variable sized objects may not be initialized. Okay, so instead, okay, hold on. Variable sized array C initialization. I think this is so simple. My brain is Swiss cheese. It's a sieve. Anyway, let's see what we got. You'll have to use memset. Okay. Is that all we need to do? Array type is not assignable. So I think we need to make it this. Variable length array on heap. Can we do that? I think I'm going down a rabbit hole that makes zero sense. I think I'm looking at something that makes zero sense. Okay, so So what if this is a pointer to that? Is that crazy? Maybe it's okay. It doesn't really seem okay. Well, if it's like that, then we can't free this because it's not malloc, right? I think it's broken. Okay, so it says um okay, let's see. No, I'm screwing it up big time. Accessing. Okay, hold on. So if we do this, then we have to dereference this, I believe. Okay, so invalid use of flexible array member on 56. Yeah, that's not invalid use of flexible array member. That totally makes sense. Okay, I think, okay, it seems like I'm crazy. Okay, so making this a pointer is crazy. Oh crap, oh crap. Oh crap, oh crap, oh crap. Oh, I have caps lock on, there we go. Okay, so whatever I did with that dereferencing, that was crazy. I've done a lot of crazy crap here. Alright, so we don't want that, that's insane. We don't want this, that's insane. We don't want this, that's insane. When we do this, that's insane. When we do this should not be like that. Okay, so array type buffer value t is not assignable. Oh, interesting. Why do I have buffer value t there? That's crazy. Okay, so that's not assignable. Okay. So I think what we need to do is not do this at all. And we need to, oh, this seems crazy. So okay, so struct initialization. Okay, so size equals size. And I'm just going to say 0. This makes it simpler. First equals 0. Capacity equals capacity. Content man, we did this in school, and I'm definitely not doing it right. Okay, so content equals and these should be commas. Expected expression. So actually, I probably need a function to return this buffer value t array. So it would be buffer value t array new content size t capacity, and then just say that seems so crazy. Expected identifier. Oh, I missed it. Brackets not allowed here to declare an array place after. Yeah. Incompatible pointer to integer conversion. Cannot return array type. Okay, can we return a pointer to it? No, we need to malloc this thing, I believe. Okay. So it would be content equals buffer value t star malloc capacity times size of buffer value t. I mean, that's really it, right? And then, okay, I'm coming full circle, basically. This is basically what I was imagining before. Would that be that this becomes a pointer to content or whatever. And then here we need to free content. And then here we need to say new content capacity. And then size of circular buffer T. Okay, so let's not do these. Let's not do that. Let's not do these. Let's just say buffer equals init buffer. Return. Okay, so here, no previous declaration for new content. Okay. No, it's buffer value T, new content, size T, capacity. So now it's set, okay, segfault quotient. Okay. So when we go to free, so we malloc here, and what is this? Where's my malloc? Oh, interesting. 14 tests, 11 failures. Okay, well, this seems better. This seems like a step in the right direction, baby. I've been at it for a while. I've been at it for a while. Okay, but it's a step in the right direction, I think. Okay, so test can read item just written. Expected 1 was 0. Read 0 at 0 where 1 was expected. Okay, so that happened quite a few different places. I'm a little put out that my printfs are not showing up. I guess let's just get rid of them then if they're not showing up. Unless I think they are gonna show up somewhere, but I don't think. Oh, unused value. Oh, interesting. Well, that helps. That helps a lot. So, unused value here. Or no. Wait, where's the unused value? On 31? Set but not used. Oh, huh, interesting. So we brought this in, then we set this. Oh, set but not used. So C out parameter. Okay. I mean, this is like basically what I was doing, but it says set but not used error. So what's the deal with that? Oh, okay, so in this one they did use both. Okay, so let me look at this again. Parameter set but not used. Parameter set but not used. Yeah, not reading from it. Dereference the pointer when you assign it. Okay, so light bitmap came in, then they set it. So is this how it has to be? That actually makes more sense. Let's see if it accepts that. Okay, cool. Wonderful. Okay, so I've got some, wow, I've got more passes now. That's cool. Okay, so test full buffer cannot be written to. Let's do that one. Expected 105 was 61. Full buffer cannot be written to. So that is in the test. Let's look. Full buffer cannot be written to. Where's that? Okay, so it says we're looking for Eno buffs. What is Eno buffs supposed to mean? Okay. So we tried to write, and there was no space left, so we're supposed to say Eno buffs. All right, let's do it. I'm getting excited. It's starting to work. I was futzing around forever and ever, but whatever. Okay, so we tried to write. There was no capacity. So here we have to say Erno equals Eno buffs. Okay, is that it? Okay, so that's good. All right. Okay. We're getting there, maybe. So test initial clear does not affect wrapping fail. Expected 1 was 0. Okay, so I mean, I think so when we clear, it sets the size to 0, and I thought that that was probably all that was going to be required. Man, so many of these things were just me making stupid typos, and it's just funny. But anyway, for this one, so clear buffer, I just set the size to 0 and call that it. So the question is, what is the actual failure? Test initial clear does not affect wrapping. Huh. I wonder why that would be. Test initial clear does not affect wrapping. Okay. So we have this. So then we clear right at the start. Okay. Yeah, I would think that that wouldn't do anything. Okay, okay. So that one's failing because some of those other ones are failing. Let's look at this first one. Test each item may only be read once. Test each item may only be read once. So we write, we read, and then we try to read, and then the expectation is that we should get an exit failure. But apparently we did not, I guess, in that case. So let's take a look. I think I've probably just forgotten something very simple. So when we read, we increase the first, but yep, I did indeed neglect to reduce the size, which is stupid, but whatever. We'll just do it now. We'll do it now, baby. So buffer size minus minus. Okay, that was it. That was the last thing. It was dumb, but hey, I'm feeling pretty good about that one. That one was a good exercise, baby. I'm guessing that it might be a little simpler in the other languages. Maybe not, maybe not. We'll see what we're dealing with. So let's go ahead and submit. Okay, wait. For this one, do we submit the C and the H file? Let me see what the help says. It says we submit... What do we submit? The C and the H files. Okay, cool. Okay, let's see where that went. So this one was listed as a medium, and I'm feeling okay about it. Okay, so that's done. Okay, we're moving on, baby. We are going to... Groovy. Okay. Groovy it is, baby. Join the groovy track. Here we go. So, local tooling. Okay, so... The preferred... Okay. So, I mean, we already kind of have Java. Like, I think... Let's just do this to start with, because I think that should be ready to go. Oh. Huh. Invalid flag dash V. All we wanted was version. Okay, 11.019. Gradle. Okay, so Gradle is required, right? I probably have that. Let's take a look. Yeah, that's probably ready to go. Nope, it's not. Never mind. So, I don't think this SDK is ready to go either, but let's see. Let's find out. Oh, permission denied. Okay. Oh, not found. Well, that's goofy. Permission denied and then not found? I don't understand that. Okay, let's try this. Here we go. You already have SDK man installed. I don't think this is going to work. Okay, so we need to do this, probably. Let's see what happens. Oh, no, 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 no. No such file. Okay, so already installed. It's at home. Okay, so there is a bin, and what's in here? Okay, so can we make it... Why did it say no such file? Oh. Okay. Okay, so now it's okay. Interesting. Okay, so let's try installing the Gradle. I think I'm okay with this. Okay, so we're fine there. But what about the groovy? Supports groovy. Okay, let's try it out. Let's try this. Let's see what happens. Oh gosh, what happened? Okay, hello world. Here we go. Okay, let's go to exercism. Groovy. Nope, not gleam. Groovy. Hello world. And let's see what happens. Interesting. All right, so Gradle test. Subsequent builds will be faster. This one seems a little slow, but not too bad. It happens, it happens. Build failed. Okay, so we did get goodbye Mars. Okay, cool. Source. Main. Groovy. Fair enough. Okay, so here it is. Okay, let's try the test. And it says it's still a little slow, but this time it is successful. So let's submit. Okay, let's see what it says. Processing, okay. Passed. Love it. Love it, love it, love it. Okay, so mark is complete. Confirm. Okay, let's go to... So now we're going to do the circular buffer in Groovy, and this one is marked as easy, because presumably it's easier in Groovy than in C. I mean, that kind of matches my expectations, so we'll see how it goes. I've never tried Groovy, but back in 2019, people were talking about Groovy for some reason. People in my class, like, it was kind of a meme, this idea of Groovy programming. I don't know. Let's see how meme-like this language actually is. So, circular buffer. So, if we try to run a test, it will say, what'll it say? Let's see. Okay, so build failed. Okay, good. So we did fail one test, and it says implementation is missing. All right, let's look at our file. Source, main, groovy, circular buffer groovy. Okay, cool. So we have a class for a circular buffer. It has a constructor, it has a clear, it has a read, it has a write, and it has an overwrite. Cool. So, I mean, this looks actually quite a bit like Java so far, but it's not Java, it's Groovy. All right, so I don't know. So I'm going to try just, I'm going to add some things here. And for the content, it's going to be, well, actually, I'm not sure. Let me look in the tests. So bat, source, test, groovy, spec. Okay, so the spec, it's going to show that we pass in a number for a capacity. So far, so good. Looks like we just write a number. So one thing, I think, I'm not sure, but I feel like groovy is supposed to be like sort of duck typed or dynamically typed, something like that. So maybe I can just, I don't know, if I'm in this file, I'm probably going to look up some syntax for groovy, but let's see. So we know we need, I'm just going to say, shoot, groovy array. Docs groovy lang org. Okay, cool. Core syntax. Identifiers. Quoted identifiers. Strings. Let's look for array. Okay, reuses the list notation for arrays. However, we also have this option for lists. What about class? We know we're using a class declaration syntax. So, okay. So we can use heterogeneous list. Okay. Okay. I think well, okay. Let's say array list. So I'm going to say array list content. Looks like size is highlighted here as a keyword, so I'm just going to change it. I'll just call it length. Okay, so for our constructor, we know we're going to want to say content equals, and then can we like, I don't know. What about using like the new keyword? Looks like that's here. No, new line. New. Okay. So I'm going to say content equals new array list capacity. Do we need semicolons? Looks like maybe not. Okay, so then I'm going to say first equals 0. Length equals 0. This capacity equals capacity. Okay. For clear, I'm just going to say length equals 0. For read, I am going to say if, where's if statement in here? If keywords, strings, numbers. So this is the core syntax. What else is there in here? Docs groovy lang org. So latest version documentation. Control. Okay, wow, this is a good amount. Oh gosh. Okay. I'm looking for the groovy truth. Well then. Control structures, here we go. If else. So do we need, okay. That's what I wanted to know. So if length is greater than 0, So in this case, we will say result equals content sub first plus length mod capacity, right? Then we will say first plus first mod equals capacity length minus minus return result. Okay. And then in this case, I guess nothing happens. I don't know. There's probably we might have to throw an exception or something. We'll see when we run the tests again. So for this one, right, we need to say if length less than capacity, then we're gonna say content sub first plus length mod capacity equals item. All right. Okay. So then length plus, and that's it. Okay, so then overwrite, we'll do the same thing. Let me just copy. Okay, but if that's not true, then content first equals item, and then first plus, and then first mod equals capacity. Okay, let's run that test. Okay, let's see. Okay, so it says expected exception of type empty buffer exception. Okay, so we'll throw that exception. So that is when we tried to read and there was nothing there, right? Oh, I think, hold on. Throw, exception handling. Let me just take a look at it. So we throw, where do we throw? Okay, I think we just do, is it like that? No. I don't think that's it. Let's see what it says. It says expected empty buffer exception, but got missing method exception. Okay, so what was this? What's the missing method? No signature. Oh, interesting. Empty buffer exception. Okay, let me just take a look. Groovy empty buffer exception. This is just some dumb syntax that I'm screwing up in a crazy way. Exercism. Okay, so class empty buffer exception extends exception. I think we go new. Do you think we do that? Let's see if that's any better. Oh, it passed. Okay, so now let's look at the rest of our tests. Source test, groovy, circular. And we have ignore. Test. Okay, cool. Oh, failures like crazy. Not necessarily unexpected. Okay, so this one. So, can read an item just written. So we tried to read no such property. Wait. No such property. Oh, no such property. What prop? Okay. Circular buffer read. Circular buffer. Okay, so it's on 24. Capacity first, length content. Missing property. And it's on 24. Okay, let's look. Okay, so on 24, result equals content, and then we say return result. So do I have to say maybe def result? I think that might be it. And then there's another one, or is there another one? Is that the only one? I think that's the only one. Okay, so is that any different? It is. Okay, so that passed. Okay, so overwrite acts like write on non-full buffer. So we said read, we got a 2, we did not get a 1. Okay, overwrite acts like write on non-full buffer. Okay. It should, but let's see. Okay, replaces oldest item. We got 2, and we were expecting 3. Replaces the overwrite replaces the oldest item in buffer following a read. Interesting, interesting. Let me clear. Okay, so items are read in order that they are written. So this didn't quite work. Sad. Sad, sad, sad. So we tried to read a 1. We got a 2. Okay, so let's see why. Okay, so result equals content first plus length mod capacity. So the problem here is likely in, I guess, either read or write. So when we write, I think it's maybe more likely in write. Let's see. So we take content first plus length mod capacity equals item, and then we increment length. Yeah, that seems like the way to do it. And then, so if length is greater than 0, result equals content first plus length mod capacity. Then we increment first. No, why am I incrementing first on read? Okay, I think I just completely had forgotten how this was supposed to work. So when we do this, we're supposed to take first. We're not supposed to take this. Yeah, that's literally it. I think that's our only problem there. Yeah, I completely spaced what it was supposed to do. Okay, so now... Okay, so that's just 2 failures now. So let me look at them here. 2 failures. All right, we're almost there. Full buffer. Okay, so expected exception of type full buffer exception, but no exception was thrown. Okay, so let's throw that exception on right. Throw new, and it's called full buffer exception. Okay. 12 failed. Oh no. Oh no. Okay, well, okay, so right. Oh, so this should be else. I didn't even look at that. Well, I sure looked at it now. Okay, 1 failed. Overwrite acts like write on non-full buffer. Oh, interesting. Okay, overwrite acts like write on non-full buffer, which, okay, so this one I think it should because I copy-pasted, but let's take a look. Write, if length less than capacity. Yeah, so it's exactly the same, and I think that's good. Oh, and again, this should be else. That's crazy that I missed that in those places. Okay, I think it's good to go, baby. All right, let's submit. Cool. All right, let's take a look. Okay, so processing. Passed. Okay, let's mark. Cool. So now, so we've got, so these are the ones we did today. We did acronym. Okay, so now we are on Scala. All right, let's join the Scala track. Interesting. I don't know what to expect from this one. So let's make sure we've got it installed. Corsair tool. Okay, let's take a look. Okay, install with CS setup recommended. Okay, let's copy. Sure, let's hit it. Okay, a good amount of jar files, I guess. We'll see how this goes. Okay. So it installed Scala, okay. All right. Okay, so that's good. Let's go try, okay, so we don't need that. So it says run CS setup, I guess. Okay, let's give it a shot. Let's see here. It was supposed to be added. Okay, so this is supposed to be in the path. Okay, so we want this. Yeah, that looks right. Okay, cool. Okay, that's good to go, I guess. Let me make sure that this path is in my ZSHRC. All right. Okay, then let's go ahead and do the hello world. Okay, let's see how the test goes. SVT test. This may take some time. All right, interesting. Shall we find out anything about Scala? Getting started. Coming from Java, Scala in the browser, Scasti. Wow. Installing. Okay, so we did some of that. Hello world. Okay, so we generate some project files. Cool. You can use IntelliJ. Seems like a good idea, baby. Seems like a good idea. Okay, so this is done. Okay, so tests unsuccessful. Okay, cool. So let's source main Scala hello world. Okay, cool. Love to see it. Okay, let's submit that. Okay, and then we'll go to circular buffer. Okay, so that's processing. Passed. Cool. All right, mark is complete. Okay, so now let's go to circular buffer, baby. Okay, so let's look at our source file. All right, so, okay, similar to Groovy, we've got some things listed here. Love it. Let's see, I don't have a constructor per se. I do see it says var capacity int here. So does that mean the constructor code goes here? I'm guessing probably, yeah. So let's say Scala assignment might be a good place to start. Chapter 6 expressions. Looks like we've got assignment down here, probably. Okay, so we can do assignment with equals, and okay. So we have the capacity already, that's good. So I'm gonna say first equals 0, size equals 0, and then we're gonna need some kind of like list. So it could be an array list again, just like in Groovy, I'm assuming. Scala array list. I don't know, maybe. Sequence? Oh, interesting. That sounds cool. Where's the link? Where's the link, baby? Scala SEQ. Okay. Classes and objects, maybe? Types? Scala SEQ. What else can we know about it? Oh, really? Oh, goodness. So we want a mutable sequence. Okay. Just a little friction getting started. It's same thing every time, it seems like. But yeah, so okay, so it looks like we want to say that hold on. Val first int equals 0. Val size int equals 0. Cool. And then val content, and then I'm going to say collection mutable sequence. And I guess that's going to be of ints in this case. equals collection mutable sequence capacity. Okay, so then for write, we have to define it as a method basically, and method types. Okay, so we do def, we put that. Okay, so far so good. And then the method body or whatever is what? We use curly brackets. I'm just wanting to quickly get started. Okay. I think we use curly brackets. Maybe. Oh my goodness gracious. All right, I don't know. I'm just gonna try. So okay, well this one's simple enough, right? So we just say size equals 0. Okay, so for read, we're gonna say if size or no, if size greater than 0, then we're gonna say val result int equals content sub first. Then we're gonna say first plus plus first mod equals capacity. I have no idea how much of this is valid. We're gonna find out size minus minus return result. And then here we're gonna throw empty buffer, or rather new empty buffer exception. Okay, I don't think we do use new in this case. At least I didn't use it up 13 lines above. Okay, so for overwrite, no, okay, let's do write first. So we're gonna say if, okay, so if size less than capacity, then content sub first plus size mod capacity equals value. Okay. Size plus plus. Is that it? And then we'll say else throw full buffer exception. Okay. And then I'm just going to copy here. Okay, so then the difference here is we don't do this, and instead we say content first equals value, and then first plus plus, and then first mod equals capacity. Okay. Oh, no. Exercism test. There we go. All right. Okay. So reassignment to val size. Okay, so Scala mutable val var, whatever it is. So two types. So we need var instead of val. Okay, so that sounds like a good start. So I think content should be val, because that's just going to be that same thing. But these should be var. Okay, how much does that help with 21 errors found? 20, oh, well, it helped with 1. Okay, 20 errors. Value plus plus is not a member of int. Okay. Plus equals 1 instead. Maybe, I'm not sure. "20 errors found." Is it going to be less or is it going to be more? Okay, 16, that's less. Okay. Not found type first. Okay, so this is not the syntax. So what is the syntax for the sequence? Okay, so this is the type. And so if to get something out of there, where do we get something out of there? This is the sequence. So is there a get or is there like an operator? What is it? Okay, hold on. It looks like it's not get. There's head, index of, find equals, filter. There's a lot here. There's a lot here. Product. Wow. Yeah, there's a good amount here. Where's the one that gets an item? And where's the one that sets an item? Get. Nope, it's not those. Two. Starts with last index is defined at, uh-oh, index of, selects an element by, oh, apply, selects an element by its index in the sequence. Let's see, so index is the index to select. So, okay, so we just use round brackets instead of square, right? I'm going to try that first. Let's see. Okay. So let's see. We had 16. Let's see if we have more or fewer. One error found. That seems like a lot fewer. Okay, so minus minus. Okay, don't know what we're gonna get. I think it will compile now, probably? Or at least get to another stage of compiling. Done compiling. Ah, okay, so something's done compiling. All tests passed. Okay, so 13 are pending. So let's go into test. Okay, so pending. We're gonna see what we get here. Test, baby. I'm very intrigued to see what might happen. Okay, 6 tests failed. Okay, cool. So let's see. Index out of bounds exception. 1 is out of bounds. Min 0, max 0. Okay, so that's gonna cause us a problem. Oh, in fact, we're getting that everywhere. We're getting that all over the damn place. Wow. Okay. So when we tried to create the sequence, uh, we didn't do it right, I don't think. Let's see. Although we didn't get that on all of them, some tests did pass. But yeah, we're getting a lot of index out of bounds where it should be min 0, max 0. Reading empty buffer should fail. Okay, hold on. Items are read. Okay, so we tried to read and index 1 is out of bounds. Min 0, max 0. No, I don't want the test. I want main. Okay. So, okay, so when we tried to do this, collection mutable sequence capacity, what does that do for us? Let's see. Yeah, I don't think I instantiated it correctly here. Do I need int there? What difference might that make, if any? Did I just... We're gonna see. I'm curious. Okay, 6 failed. Okay, so it's still out of bounds. So wait. Okay, so it seems like... Okay. Alright. Scala object instantiation. Scala object instantiation. How do we do it? Really new. Yes, that's me. Really, really new. Okay, so we... Okay. So in the apply, I'm nervous about one thing. So in the apply, we get the element, but how do we set an element? That's update, right? So for update, we have to, okay, replace at given. So I don't think I've been using update, so that could be a big problem. Oh, interesting. Index out of bounds. This one also does index out of bounds. But I think I need to be doing update and not apply. But there might also be something. So Scala update method. Okay, I'm just gonna try calling update instead of doing what I did. So instead of doing this, I'm gonna say update. All right, we'll pass this index in and then value. Is that what I thought the update looked like here? Index and element. So that's for write, and then also for overwrite, same thing. And here as well. I don't know. I think I'm still going to get the same errors. I don't think that's going to fix them. But I think that might be necessary. I'm not sure. Okay, 6 failed. Yeah, 1 is out of bounds, min 0, max 0. Okay. Scala sequence object instantiation. Okay, what happened? Yeah, what happens here? So trait sequence a type, object sequence a value. Oh gosh. Object sequence, sequence factory, Scala collection sequence, okay. I'm so nervous. Okay, shoot. Is list. Okay. What else can we find about this? That's not it. Okay, so we're do we have something to set the length? So can we set the length? Length. There's something down here. Length is pad 2. Segment length. It feels like maybe I've used the wrong data structure here. So I'm going to try pad 2. Pad 2, right? Capacity 0. What is that going to do? $14 succeeded. Let's move on, baby. That's not too bad. That's not too shabby. That's not too shabby. I don't think sequence was the right data structure at all, but hey, if it works, I'm not going to refactor. I'm going to move on. That's the whole idea here. All right, let's submit. Okay, here we go. Did it submit? Okay, processing. Let's close these other ones out. And we are going to move on. Okay, so it says passed. And a mark is complete. Confirm. Okay. So that passes off circular buffer. Now we're going to go to parallel letter frequency in Go. Hooray. All right, so let's join the Go track. Practice mode, local. Let's look for the tooling. And I mean, I think Go might probably be ready to go. Let's take a look at Go version. Okay, so that's fine. Let's try the hello world. Okay. Okay, so we got Goodbye Mars, love it. So let's do hello world. No. This, yes. Okay. Hello world. Okay, pass, exercism, submit. This guy. Love it. Let's take a look. Processing. Okay. Okay, so that's completed. All right, so now we're gonna do this one. Okay, let's look at the README. So for this one, parallel letter frequency. Count the frequency of letters in texts using parallel computation. Oh, interesting. So parallelism is about doing things in parallel that can also be done sequentially. Oh, wow. So a common example is counting the frequency of letters. Create a function that returns the total frequency of each letter in a list of texts and that employs parallelism. Okay. So Go supports concurrency via Go routines, which are started with the Go keyword. It's a simple, lightweight, and elegant way to provide concurrency support and is one of the greatest strengths of the language. Love it. You may notice that while this exercise is called parallel letter frequency, you don't see the term parallel used very often in Go. Gophers prefer to use the term concurrent to describe the management of multiple independent Go routines, processes, or threads in other language contexts. Although these terms are often used interchangeably, Gophers like to be technically correct and use concurrent when discussing the seemingly simultaneous executions of Go routines. All right. So while we can plan for our programs to run in parallel, and at times they may appear to run in parallel, without strict knowledge of the execution context of our code, all we can guarantee is that processes will run concurrently. In other words, they may be executing sequentially, faster than we can distinguish, but not strictly simultaneously. All right, so, okay, so this is what we know. All right, so interesting. So frequency of letters. Okay, so I feel like if we're talking about this, then I feel like what we're going to do is we're going to decide that we want some number of Go routines. So we'll decide on n Go routines. And then I think we're going to split the text into n substrings, right? And then pass each substring into one Go routine. I'm guessing that's what we're going to do. Right? So let's take a look at this. Okay, interesting. So we have a frequency map of runes to ints. Okay, cool. Counts the frequency of each rune in a given text and returns this data as a frequency map. All right. Concurrent frequency counts the frequency of each rune in the given strings by making use of concurrency. Okay, so this one is already ready to go, right? It'll just say frequencies is the frequency map. Okay. And for our in range text, we'll increment the frequency and then return. So that one is good to go, I guess. So then let's see. So for concurrent frequency, I am not sure that we're going to use this same technique. So one problem is that if we use a frequency map like this, it's not safe to use, like it's not thread safe. So we would have to use a mutex, and then each go routine would have to wait for it to be unlocked in order to add a letter. So that approach, I think, doesn't really make sense. So instead, I believe what we're going to do is we're going to take a bunch of these frequency maps and combine them after we've finished going over the text, which I guess is fine. Yeah, I think that's fine. Is this actually going to work? So, like, what if the frequency is not assigned to a number? It'll just be a zero value at first, right? I think that will work, but I'm not sure yet. So, in short, I think that we can probably go ahead and use that frequency function. So, I guess we want to know, like, how do we decide how many go routines to use? All right. Oh. Not that. Okay, so I think, let me just take a look at the test. I'm going to have to step away for a second again. Oh my gosh. Okay, so here is our text. Fine. Sure. Okay, so I think go find number of CPU threads. We should be able to like find the number of CPU threads, I think, and then use that for the number of go routines. Yeah, let's do that. Runtime num CPU. Okay, so runtime, and then num CPU. Num CPU, right here. Number of logical CPUs usable by the current process. So I think I'm going to use this for the number of Go routines. That being said, I gotta step aside for maybe like 5 minutes, honestly. Be right back. Okay, let's go then. So, whoop, oh gosh. Here we go. So in our file, okay. So first of all, we want to say, let's import runtime. Okay, so then we'll say n, like that. Okay, so then we'll use n. So let's say for I equals 0, I less than n, I plus plus. We will go, we'll say, let's make a, so we'll say maps equals make, let's see, how do we make a slice again? Make slice go like, yeah, creating a slice, yeah, in the tour, sure. Okay. Slice of frequency map, and we'll make n of them, okay. And then here we'll say maps sub I equals go frequency, but we have to get the substring first. So we'll pass in the subtext. Okay, so the subtext is going to be oh wait, it passes in an array of texts. So wait a minute. So is the idea, so okay, for some reason I thought I was going to be breaking up a single text, but if it passes in different texts, then I guess the idea is to actually just do one for each text that's passed in. So I guess I don't need this. Don't need that. So this will be len texts. This will be len texts. Wait a minute. Okay, so we don't need that. Oh yeah, we can't do that. We have to go, let's see. So we're gonna go func and we're gonna say maps sub I equals frequency texts sub I. And then I guess we need to have some way to tell when we're done, right? So we're gonna have a channel, and where's make channel? Okay, so just like this, make channel. Actually, maybe... Well, I guess it doesn't matter what it is. So here, we'll go like that. Okay, so then we'll go again for I equals 0, I less than len texts, I plus plus, and then we'll take that struct off the chan, so we'll go C. Okay, so then that means it's done, right? Okay, so what is this? Loop variable I captured by func literal. Oh, it doesn't like that very much, does it? Probably. Yeah, it probably makes more sense to just pass that into the channel. So I'm going to say we are not going to do this. We're going to say for text in range texts. And so then this is going to be text. And then this channel is going to be take a freak map. And then this is going to go C. We're not going to do that. Okay, so then when we do this, maps, oh, does this make sense? It doesn't, it really doesn't, does it? Actually, no, it's fine. It's probably fine to do it like this. So maps sub I, yeah? Cannot send to non-channel maps. Oh, wait. How do we read off the channel? I did it wrong here. Oh. Is that it? Non-name maps sub I. Oh, shoot. So you're supposed to go receive from C. Hold on. There we go. Okay. And then what is this? Loop variable text captured by func literal. Okay, so it doesn't like that. Loop closure default. Okay. I guess I can do it like that. I think I made it a little more complicated than I should have, probably, but sure. So then I'm going to say... So we're going to go through all the maps and combine them. So I'm going to say result. We already have the result defined, so we just need to go for map in range, and map is a keyword, so I'm just going to say m. In range maps, and then for kv in range m, right? I think so. And then we're going to say result sub k plus equals v. And I believe that's it. I think that might be it. Okay, let's see what it says when we test. Okay, that's not it. That's not it, baby. No. Panic. Assignment to entry in nil map. Okay. So we have to actually declare it first. So result equals make, and that's gonna be map room int, like that. Pass. Okay, so in the tests, testing short. Skipping benchmark in short mode. Okay, was I in short mode just then? I can't actually tell. Go help test. So two different modes. Oh. So we've got all this text, fine. Original frequency. Test concurrent frequency. Test sequential frequency. Okay, so then these are being skipped. So I'm just gonna get rid of this skip. Still says okay, let's submit it. That was pretty straightforward. And they did say it's a strength of the Go programming language. It does make it relatively straightforward, right? Did I finish it very quickly? No, but it makes it relatively straightforward. All right, let's take a look. It took me a while, but it was nothing complicated or difficult. It just took me a while because I'm kind of dumb. All right. Processing. All right, we done? We good? Passed. Okay, so let's submit. Okay, so that means that we have done a Go. All right, the next one is Java. Oh, baby. Join the Java track. Yes. Practice mode, local. Okay, I think this Java should be good to go. I'm just going to try the hello world without looking at that other stuff. And I'll look at that other stuff if needed. But I think Java is good to go. Okay, so it says Gradle W permission denied. Okay, so how about now? Interesting. Starting demon? Seems like kind of a lot, but okay, whatever. It happens. Build failed. It says... Okay, so we got a wrong string. Okay, so we're good to go. Source, main, Java, greeter. Okay, sure. Test again. And there we go. Let's submit. Source main Java read. Okay, here we go. Okay, cool. Okay, so now we're going to try the parallel letter frequency. Let's take a look. I don't know how bad this is going to be, but we're going to find out very quickly here. Parallel letter frequency. Okay. Let's look at the README. Let's see how different it is. Okay, so it just says parallel letter frequency. Count the frequency using parallel computation. A common example, counting the frequency of letters, sure. As a stretch goal, consider if your implementation will work for characters with diacritics or accents. All right. Probably not going to worry about that. Let's see what's in the test. If they don't have it in the test, I'm not going to do it. At least not right now. It'd be good for a stretch goal, sure. Okay, so here's some text. I think this is fine. Oh, they do test Unicode letters. Interesting. Okay, well, we'll see how this goes. All right. So let's open up our source main Java parallel file. Okay. So we have count letters and we have parallel letter frequency. Okay, so we have a constructor. Okay. I'm not quite sure what we need this constructor for, but sure, we'll just say this texts equals texts, string array texts. Okay, so then count letters. So we want to do this as a parallel thing, right? So however many texts there are, we're going to try and start a new thread. It's going to be pretty similar to what we did with Go. It might not be quite as straightforward. So I'm not sure how you even do this in Java. I'm not sure I ever have. I don't think I ever have, honestly. So let's just see. So, oh, you know, I've done something needed. I don't know. Let's just see how we start a thread. A thread is a thread of execution. So do we have a channel in Java? Okay, this is a different concept of channel, right? This is not like the common channel we know from Go, I don't think. Safe for multi-threaded access. Wait. Open connection to an entity such as hardware device, file. Okay, that's fine. That's not what I'm looking for. Okay, let's look at this. JCSP. Okay, I mean, I guess that's okay, but so as with Go, a Java program using channels must be designed not to deadlock. The implementation of low-level concurrency primitives in Java is very hard to get right. Okay. I don't know about that. I'm looking for like the typical way in Java. What's the typical way if we have some threads going? What's the typical way for the thread to tell us that it's done doing something? Let's just ask. What's the typical way for a Java thread to signal that it has completed its work? A waiting thread periodically checks the flag's value. That's crazy. Um, is that the way to do it? Uh, okay, so we can use a runnable, but like there are other, okay, so hold on. So the thread implements runnable. I don't know how we do this in Java. I'm gonna need to spend some time here looking at a few things. Create a new class that extends the thread class? Really? Thread's not abstract. Hmm. Okay, so, okay. Create a new class that extends the thread class. And then you call the start. Start. Causes the thread to begin execution. Okay. Is this gonna be the one that thwarts me? Oh gosh, I hope not. It could be though. It could be. Yeah, Go sure makes it easy, doesn't it? Okay. So yes, I think this guy is right. We want to create a new class that extends the thread class. So that's going to be part of what happens. And we're going to have a run method. And then we're going to wait for each thread to be done. I just haven't decided yet how we find out when the thread is done. Let's see what else is here. Oh gosh, no, stop. Countdown latch. A future. I don't know about that. Okay, callable. Okay, this sounds smart. Java block until condition, sure, maybe. Synchronized. Let's see. This is Java, right? Java synchronized. Let's take a look. Well, I don't need to do that. I just need to wait until everybody's done so that I can get their... I need to wait till everybody's done so that I can get their completed maps. Honestly, I probably am gonna do polling. It's definitely the least preferred solution, but it does work, right? It can work. I'm gonna do polling, actually. I am gonna do polling so soon. Okay, so we're gonna have a class, letter frequency thread. Okay, so that's going to be extends thread, and thread is going to be from Java lang thread. Okay, so I don't think we need to open it or to import, or what is it called? Import it, yeah. Okay, so then we need to override the run. So this is going to have a public map character integer result and a public boolean done. And then it's going to have a run method, public void run. Okay. And I guess it probably needs a constructor or to, yeah, how are we going to instantiate that? With a constructor, probably. It's fine. So public letter frequency thread. So I guess at this point we pass in the string text, probably. Yeah, that would make sense. This text equals text, sure. This result equals new map character integer. This dot done equals false. Okay. What is this? Map is abstract. Oh. Hash map. Yeah? Oh, it's not hash map. What is it? What are the different... There's tree map, right? Okay, I think we want hash map, but we have to import it, right? Hash map. Import Java util hash. Yeah? Okay. Okay, so then when we run, we're gonna go for int I equals 0, I less than this, or let's just say text length. Let me see, Java string length. It's a length method, okay. I plus plus, and then we'll say if result dot, so result is a map. Oh, do I not have, oh no, I don't have IntelliSense completions for Java. Oh man, I need these. Okay, Java map. It should just be has, right? Or something like that. Has or contains. Contains key. Contains key text sub I. Result dot put. Dot put text sub I, and then result dot get. Is it get? Get text sub I plus 1. Right? Else result dot put text sub I 0 or 1, excuse me. Okay, so then then at this point we say done equals true. Yeah? Okay, so what is this complaint? Error something expected. Okay, I did leave that out. Array required, but string found. Let's see. Oh, Java string. Let's just get the deets. So to get something out of a string. Oh goodness. Char at. Char at I. This will also be char at I. Yeah. This will be char at I. This will be char at I. Yeah. Missing return statement. Okay. Okay, so Java sleep thread.sleep. So do we have to import it? That's all I wrote. It looks like not. Okay, so basically we're gonna go for I equals 0, I less than text's length, I plus plus. We're gonna say letter frequency thread t equals new letter frequency thread texts sub I. Then we're gonna t dot start. Cannot find symbol length. Oh, texts is an array. Let's see. Java array length. It is wait a minute. Okay. Is it like this? Okay. Okay, so then we're gonna wait. Oh, but we need to put these into an array of letter frequency threads. So we're gonna say letter frequency thread array t equals new. Okay, do that. Is that it? That's it. Okay. So now this is going to be texts t sub I, and this will be sub I. Yeah? Okay, so then for, or I'll just say, I don't know. Let's see. So then we need to be able to check. So I'm just going to say while true. Thread sleep 5. I'm just going to say 1. Java thread sleep. Yeah, it's this. So we just basically block for no reason. It's so dumb, but whatever. So we'll just do sleep with milliseconds, and that should be fine. Okay, so I'll just sleep for 1 millisecond, I guess, and then say if, or let's say, Boolean should continue equals true, and for, let's just say, letter frequency thread x in t if x dot done, or let's say if not x dot done, then should continue equals false. And then we'll say if should continue break. Okay. Sure. And then when we get to here, we're gonna combine all of these things. So we'll say map character integer result equals new hash map. And then I'll just put, whoops, not there. Character integer. Okay, and then we'll say for and then we need to go through everything in the map. So I think in the map we can go through like we can go through all of the entries. Let's see, entry set values, return a collection of the values. If we do a set, can we iterate? So this one is iterable. Okay. So we'll do entry set. Where's that? Entry set. Yeah, here. So we'll go for map entry character integer entry in x dot, that's the result in x, gosh, I didn't think I clicked there. I don't know what I did. X dot result, and then we'll say result dot, and again it's put no, we have to say if result dot, what's it, contains key, and then this entry should have a key on it, I believe, right? Get key. Entry dot get key. Then result dot what is it again? Put entry get key result dot get entry get key plus entry get value, right? Entry get values here. Okay. Else result dot put entry get key result get entry. No. Okay, so this time we don't get. We just go entry get. Okay. Wow. Okay, I'm messing up everywhere. Okay, so cannot find symbol map entry. So map entry comes from import Java util map entry, I think. No? Okay, so where does it come from? It comes from map dot entry. Okay. And so then this was from get entry set or whatever. Entry set. Okay, and then what about this one? Cannot find symbol. Boolean should continue equals true. If should, okay, illegal parenthesized expression. Oh, there we go. Okay, so then this one. Unreported exception, interrupted exception. Let me see how that is on here. Let me do that. Try without catch. Oh. Okay. All right. So, no more editor hints. Man, this one seems dumb as heck, but here we go. Okay, let's see. Yeah, let's do that. Okay, so we skipped most of the tests, but we did pass one, so hey. All right, so now let's go into the tests. Source, test, Java. Okay, so disabled. Okay. All right, so we failed almost all of them. All right, not unexpected necessarily. Okay, so null pointer exception. Oh my goodness gracious, null pointer exception. That was on 62. Okay, well, I like that one because at least it's usually easy to fix. I mean, yeah, it's usually easy to fix. So let's go to 62. Okay, so result put. Okay, so entry shouldn't be null, I don't think, but is result null? Well, that shouldn't be null either, I don't think. Get key, get value. Oh, okay, so which one is null here? I'm not sure. Usually easy to fix, but maybe not this time. Okay, so result contains key. So was there no get value? I don't know. Let's look at another one. So 13 completed, 9 failed. Okay, so most did fail. So null pointer exception on 62, which was, okay. Yeah, I don't know that one yet. 62. What else? Shoot. So it's just 62 that has the null pointer exception? Okay, I want to fix that first, but I don't know why I would have that on 62. Because we already checked that result contains key. Result put, entry get key, result get, entry get key. Entry get value. So is entry get value? I don't know which one is null. Can we do system out print line? result, entry, maybe just that to start. Is that going to help in any way? We're going to see something come out. Perhaps not. Let's see. So we run exercism test. No, I don't think I saw it come out. Okay, so expected. Wait, test ignore white space. Oh, really? Oh, I don't think we had to do that in the Go one. All right. So ignore white space, really? Okay. Fair enough, I guess. So, let's see. So when we're adding something in, we need to make sure that it's not white space. So I'm going to say if text char at I. Okay, so if we do a char at, we get a char back. And then if we have a char, do we have like a method to say if it's white space? There's trim. No. Let's see. Java char is white space. Let's see. Let's see. Let's see. Okay, let's see if we can import that. Oops. Import java.lang.character.is white space. Wait, it's a static? So whatever I tried to do, we cannot do it. If, oh, what does it say? Oh, just a misspelling here. So did something pass that didn't before? Maybe. Oh yeah, ignore white space passed now. Okay. Null pointer exception. Okay, so I still don't know about that. What about this one? So expected B2, C3, D1. I got nulls here. Uh-oh. Uh-oh. B null, C null. Oh, that's effed up. Okay. Interesting. So let's see. So am I putting a null in somewhere? I'm putting a 1 there. That's good. But there are a few places I might be putting a null. So it has to be integer, but apparently it can be null, which I'm not happy about right now, because it is null. Oh gosh. So is entry get value coming out as null? That seems crazy. Get value. Oh man. I'm gonna be here forever, it seems like. Okay. Expected nothing? Oh, ignore numbers. Oh, crazy. Character is numeric. Java. Is digit. Okay. So we should be able to at least maybe fix that one. Or is digit text char at I. Okay, just 7 failed now. Ignore punctuation. So in reality, I think it's supposed to be just letters, which is, it's just funny because it wasn't that way in the Go one. It's, I don't know. I just didn't know that that was what was expected. Is letter. So if not, is letter. Okay, 6 failed. So 1 by 1, making more sense maybe. So what's this one? Test combination of lower and uppercase letters. So I've got nulls all over the place. That's crazy. I don't know why I'm getting nulls. Okay, so apparently we're supposed to go lowercase. Yeah, it seems that we are supposed to go lowercase. I don't know why these are coming out as nulls. That's the main thing to figure out. But yeah, apparently we're supposed to go lowercase. So I'm gonna say Java char lowercase. So that's another static. Okay. To lowercase. Is that what it is? So I'm going to say character C equals text char at, or no, so to lowercase text char at I. So then we'll use that C. Contains key C, put C, result.get C. Wait a minute. Okay. That's more clear. And there they go. Okay, so that was just a confusing dumbness for sure, for sure. So yeah, that's everything. Let's submit. I hate that one, actually. That one really, really needs refactoring badly. But I want to move on, baby. I want to move on. I want to see what the next language is. I'm just going to do one more for today. This next one will be the last one. Oh, really? Try removing statements. Oh, you know what? Honestly, that's good feedback. Okay, processing. All right, passed. So let's mark as complete. Okay. All right, that one needs refactoring badly, but I'm gonna move on. All right, last one for tonight. Let's see. I didn't look at what it is. What is it? It is Elixir. Oh, this is gonna be the second one. I did Roman numerals in Elixir earlier, so this is the first instance of a repeated language. That's great. Okay, so let's hop on to this one. Cool. So I'm guessing that doing some parallel computations in Elixir is going to be easier and nicer than in Java. I think it's probably going to be similar to how easy and nice it is in Go. I'm guessing. I'm hoping. I mean, honestly, once you know how to do it in Java, I'm sure it's really great. It's just easier to know how to do it in Go. And I'm guessing it's probably easier to know how to do it in Elixir as well. All right, so let's look at our README. Okay, so count the frequency of letters in text using parallel computation. Parallelism is about doing things in parallel that can also be done sequentially. A common example is counting the frequency of letters. Okay, so not a ton of info on here. Take a quick look at the help, maybe. Okay, running the tests. Okay. And then what is in lib? Frequency. Okay, count letter frequency in parallel. Returns a map of characters to frequencies. The number of worker processes to use can be set with workers. Okay. Okay, let's just look this up. Elixir worker processes. So in Elixir, all code runs inside processes, and we can spawn. Okay. So processes are not only the basis for concurrency in Elixir, but they also provide the means for building distributed and fault-tolerant programs. Amazing. So should not be confused with operating system processes. Extremely lightweight, even compared to threads as used in many other programming languages. It's not uncommon to have tens or even hundreds of thousands of processes running simultaneously. Nice, nice. And sending and receiving messages between processes. Yes, this is going to be great. So we can use the spawn function. Sounds like a winner to me. And we just pass some kind of function in there. That's cool. Very cool. So far, so good. And then let's see. Okay, so we can send and receive. So does receive block? The process that sends does not block on send. It puts the message in the recipient's mailbox and continues. Great, love it. And in particular, a process can send messages to itself. Fine, sounds good to me. If there's no message in the mailbox matching any of the patterns, the current process will wait until a matching message arrives. Sounds nice. And a lot of this does sound comparable to what we typically do in Go as well, right? So if we're gonna block until something comes in, that's awesome. All right. So a timeout of 0 can be given when you already expect the message to be in the mailbox. Okay. So if we time out, then we'll just keep going, I guess. Okay. Let's put it all together and send messages. Okay, so we spawn something which sends. Okay, so when we sent, we included self on there. This one sent to itself. Okay. And then the parent received and got this guy from somebody and included a PID. Okay. Inspect. Okay, so the majority of times we spawn processes in Elixir, we spawn them as linked processes. Okay, let's take a look. Runtime error, oops. Oh gosh. It merely logged an error, but the parent process is still running. That's because processes are isolated. Love it. Okay, so if we spawn link, then what does this do? Oh, interesting. Okay, so tasks. I don't think I need that. I think what we need to do is just spawn however many functions we need, and then we will just wait until we get the messages from all of them saying that they've finished, and then we'll finish. I mean, it seems really simple. It seems a lot nicer than what we had in Java. It might take me a while, though, because I'm not familiar with the syntax, or I'm not really very familiar with functional programming paradigm in general. But I'm gonna give it a shot here. So, let's see. So, module frequency, here's the doc, and here's a spec. We're gonna return a map of characters to frequencies. Okay, so let's take a quick look at Elixir map. Go to key value data structure sounds like a winner to me. Okay, so we just do it like this. That sounds great. And so if we just start with an empty one, then we can put things on there, basically, I guess, probably. Okay. Okay, let's try to start. So we're going to get texts. Workers is going to be a number of workers. Let me look at the tests. Okay, so we've got a bunch of text again. That's good. And quite a few tests. Cool. So no texts. One text with one letter. Okay. So for the most part, let's see. So workers. Oh, we are supposed to ignore numbers again, apparently. And we are supposed to lowercase again. Okay. And so then this one apparently said 2 different workers. And then this one is many small texts, and they said to use 10 workers. Okay. Interesting. I think this one is going to be the most complicated of the bunch. Kind of excited, but nervous. Okay, let's see. Count letter frequency in parallel. Okay. Number of worker processes to use can be set with workers. So what does workers come in as? Is it just, hold on. I'm I'm feeling a little fried. I might save this one for tomorrow. Close to the 5 hour mark? Yeah, I might save this one for tomorrow. I still feel like energetic-ish, but just a little fried on all the coding. I didn't even finish a very good amount today. Maybe kind of a good amount. Okay. I think I should be able to finish this one. So we want a frequency helper probably, right? So def frequency helper, which takes a text. And if we want a spec for this one, frequency helper is going to take a string. Oops. Actually, I don't know. I'll leave that alone. Let's just say it takes a text. We know it's going to return a map. So then here I'm going to say, let's assign a map. So, or declare. Sure. So I'll say map equals this. No, this. There we go. And then we're going to say, so this is one of the ones where we can't actually use a loop, right? So if we get a string coming in, what is this? Okay, elixir string. We can do to char list, and then if it's to char list, oh shoot. Oh no. I guess I'm wondering if we can run like a for each on this. Elixir for each. Maybe not. If not, that's fine. So I think what we do is we just take the first character off the string and then recursively process the rest, I believe, probably. So if we're using a string and we want to take each character off the front of the string in turn, and then recursively process the rest. Oh man, I am feeling fried actually. Okay, hold on. One sec, please. Yeah, you know what? I am gonna stop and I'm gonna leave this for tomorrow, and I'm sure it'll seem much. I don't know if it seems hard, or I think I've just been at it for a while today, and I'm not prepared to go into this one today. So I am gonna end, and I guess that's it for today.